Maths. The first video I showed in my channel. If you want to see 9.1, it's in my channel. Now I'm on 9.2. 9.2, it says, sketch the graph of f of x. Clearly indicate the intercepts with the axis, our axis and the turning points. So 9.1, we got the turning points, which is a 3 and a 0, and this minus a 1 over 3, 500 over 27. So for you to draw, you need turning points, you need the y-intercept. Now let's look for y-intercept. Y-intercept, you set. So you set your x to be a 0. So remember that our f of x was actually the first one, x plus a 2, and x squared minus 6x plus a 9, or it was x cubed minus 4x squared minus 3x plus 18. So we'll rather use this one here to use to get our f of 0, which is going to be bracket 0 cubed minus 4 of 0 squared minus 3 of 0 plus 18. So we'll definitely get 18. So the coordinate is actually a 0 and 18. So we keep this coordinate. It's going to be the y-intercept. So it's going to be the y-intercept. Now, for us to get the x-intercept, you choose. So for the x-intercept, they are also called the roots of the graph. We set the y equals to 0. Or we can say f of x is equals to 0. Now we choose this one here for that. So we say our f of x is equals to a bracket x plus 2 and x squared minus 6x plus a 9. Why do we choose this? Because it has already been factorized one part here. So we only need to factorize this trinomial there. So we will say x plus 2 bracket x squared minus 6x plus a 9 is equals to 0. Now, there we say x plus 2 is equals to 0 and x squared minus 6x plus 9 equals to 0. So x is equals to minus 2 and x minus 6x plus 9 equals to 0. So this is one of the answers which we have. And now we have this to factorize. But I want to go on a longer method for to check if it has got roots. So to check if my x squared minus 6x plus 9 equals to 0 has roots. We use the discriminant, which is called a delta. The delta is equals to b squared minus 4ac. Why did I go this route? Because I just wanted to teach about the discriminant. So delta is equals to b squared minus 4ac is to check if the trinomial has got roots. If my delta is equals to 0, here's equal real roots. If my delta is less than 0, here's non-real roots. If my delta is greater than 0, here's different real roots. So let's check if I have the roots or not for x squared minus 6x plus a 9 equals to 0. Now here our a is a 1. Our b is a minus 6. Our c is a 9. So b squared minus 4ac is the bracket of negative 6 squared minus 4 multiplied by 1 multiplied by 9. That is to say 36 minus a 36. That gives you a 0. Therefore, delta is equals to 0. So here's equal real roots. So if you have got from this trinomial or the quadratic equation here, so x squared minus 6x plus 9, we are expecting equal real roots. So x minus 3, if you factorize x minus 3 is equals to 0. So x minus 3 is equals to 0 and x minus 3 equals to 0. So x equals to 3 and x equals to 3. So we say x equals to 3 twice. So all the roots, the roots are going to be, all of them, x equals to minus 2 and x is equals to 3 twice for the roots. So we basically have calculated the turning points from 9.1, which are 3 and minus, and this minus 1 over 3 and that, and the y-intercept and the x-intercept. Now, to sketch the graph, remember we are sketching the graph. We are not plotting the graph. We are sketch the graph. So sketch the graph, we estimate our points. Normally, if you want to estimate the points, we have to use, let me try and use different colors for different sketch. Now, for the turning points, I am expecting to have a 1 over 3. This is my guideline. And I am expecting to have a 3 here. So I'll take back my blue color because I need the blue color. So this part here is a negative 1 over 3. This part here is a 3. And this one is x-axis. This is y-axis. Now, I am expecting to pass through 18. So I can put 18 here. And I'm expecting to have a negative 2. And I'm expecting to have a 3. So I'm going to come there and pass here also and pass there. But this part here, remember, 500 over 27 is approximately 18.52, which is 18.52 is a higher point there. So I will draw with another color, which is red. So basically, I might draw it perfectly or I might draw it badly because it's a freehand sketch. So it's going to be there. That's beautiful. So this is my f of x drawing of the cubic function. So this part is a local minimum. So this is the local minimum and the local maximum. The local maximum. So This is the graph you are expecting to have on 9.2. Now we go to 9.3. 9.3 says, for which values of x will x dot f of x less than that? Okay, let me try and explain with a different color. So this x here is representing all values on x-axis. And this f of x, it was f prime. There's f prime of x. F prime of x, this one here, it represented the gradient of the graph. The gradient of the graph here. And this last part here is telling you must be negative. It must be negative. So let's look at our graph again. So we have our graph of f of x, which we draw before. So if you look very careful, our gradient, our f prime of x, which is in green, is the gradient. So the gradient, when the line is like this, is positive here, positive gradient. So I'm using green as show the gradient for green is the gradient. So this part here is a negative gradient, it's positive gradient, is positive gradient. So this is positive gradient. All these are positive gradient. Now let's look for our x values. Let's use red to show, or let's use pink to show for x values. So x values, this is negative values for x, negative values, positive values, positive values, positive values, positive values. Let's look at how our graph is divided. Now we can use black to do our final. If we move from here to there, and we also have from here to there, there is something changing. We also have from here to there. We only consider sections that are changing in sign. So remember that the gradient is positive multiplied by the negative. So negative and positive, it gives you the negative. So I've got a negative here. This is negative here, negative and negative. So I've got a positive section here. And this is positive and negative, gives you a negative section here. And a positive gives you a positive section here. Remember, we are looking for the negative. So we are looking for this section and this section. So for the first section, for this section here, it's in between. So x is greater than 0, but x is less than 3. For this part here, remember, I'm not putting brackets. I'm just showing the space, because some people will say square bracket is inclusive and the round brackets are. This is not a square bracket. Okay, we can remove the brackets to make other people more comfortable and put like this, and like I think it's better. For this one here, we are only going for forever. So it means x is less than -1/3. So our final answer is x is less than -1/3, and x is an element of open bracket 0 to 3. Or we can use another notation that will definitely say 0x here. X is greater than 0 but less than 3. This is how we do it. Please subscribe. I'm going to put more cubic function on my YouTube video. Subscribe my YouTube video to get more of this. Thank you very much.